In this video, we're going to start looking at quadratic equations. A quadratic equation can be written in the form ax squared plus bx plus c is equal to 0. So this is a quadratic equation in x. It's quadratic as the highest power of x we've got is x squared. We're going to start off in this video by looking at factoring quadratic expressions and solving quadratic equations by factoring, and then in later videos we will look at completing the square, the quadratic formula and graphing quadratic equations. Okay, let's start off. The easiest quadratics to deal with are when we have, for example, x squared is equal to 49. With these particular examples, we can simply square root both sides of the equation. If we do that, we're going to have now x is equal to plus or minus the square root of 49. So x is going to be equal to plus or minus 7. A common error is that students say that there's only one answer, and that's 7. If we just consider though, negative 7 multiplied by negative 7 also gives 49. So 7 times 7 is 49, negative 7 times negative 7 is also 49. So this particular example is where we have ax squared plus b is equal to 0. Let's now look at the next sort, and I'll give an example of this. X squared plus 2x is equal to 0. What we do here is look at the terms and see that we can factor these two terms. The common factor here is x, so we take x out. That's going to leave me x plus 2 is equal to 0. So I've taken the common factor of x out, and I say to myself, what do I need to multiply x by to get x squared? The answer is x. What do I need to multiply x by to get positive 2x? The answer is plus 2. In this particular scenario, we've got x multiplied by x plus 2 is equal to 0. If we just consider now, if I have, for example, 6 multiplied by 0, that is going to be equal to 0. If we had 0 multiplied by 5, that too will be equal to 0. In solving this, we can say that either x is equal to 0 or x plus 2 is equal to 0 to give us this value of 0. Therefore, if x is equal to 0, we can simply write now that x is equal to 0. If x plus 2 is equal to 0, then x would be equal to negative 2. And we can see that we've got two solutions to this quadratic equation. These are of the form ax squared plus bx is equal to 0. So we have an x squared term and an x. Let's now look at the next scenario. This time I'm going to have x squared, I'm going to have now minus x, and we will have now minus 12, and that is equal to 0. So this time we can see that we've got a constant. A constant is a term independent of x, or one that doesn't have x here. What we do in this particular scenario is try and factor the quadratic equation. So I write it in the form ax squared plus bx plus c is equal to 0, which we've done here, x squared, x, no x. And we set up two sets of brackets. So what I say to myself is, now I need two numbers that multiply to give the c term and add to give the b term. So we're looking for two numbers that add to give negative 1 and multiply to give negative 12. If you're unsure, you can simply consider the factors of 12. 1 times by 12, 2 times by 6, 3 times by 4, and then of course the next one would be 6. So which of these has a difference of 1? Well, if we look, that's got a difference of 11, a difference of 4. This has a difference of 1. X goes in each of these brackets. I now consider which is going to be the positive and the negative. We know that 3 and 4 are our numbers. I need to have now negative 1. If that's the case, I'm going to have now negative 4 and plus 3. So these two numbers, negative 4 multiplied by positive 3 gives negative 12, and then plus 3 minus 4 when added, or negative 4, give negative 1. So we want two numbers that multiply to give this C term and add to give the B. At this stage, we're exactly the same as we are here. Either this or this is equal to 0, as if we multiply them, that will give us 0. If that's the case, then x plus 3 is equal to 0, which means that x would be negative 3, or x minus 4 is equal to 0, which would give us x is equal to 4. I've gone ahead, factored this quadratic equation, and then solved by considering that these now give me a value of 0. This is of the form ax squared plus bx plus c is equal to 0. So here we've got no c, and here we've got no term in x. I'm just going to do another one of these. If we had, for example, x squared, then I'm going to have now on here, and we will go for, let's go for minus 8, and then we will have on here now, let's go for now, we'll go for minus 2x is equal to 0. This is a quadratic equation. I'm going to look to factor and solve. If we just had this here, this would be an expression. It becomes an equation when we have an equal sign. I need to rewrite this in the form ax squared plus bx plus c. So we're going to have x squared minus 2x minus the 8 is equal to 0. We need two numbers that multiply to give negative 8 and add to give negative 2. So setting up the brackets, I'm going to put x in the front of each bracket. If we just consider 1 times by 8, 2 times by 4, and there are no other factors. These two have a difference of 2, which we can see here. So I'm going to have now the 4 and the 2. We just need to consider which is a positive and a negative. We can see the negative will be the 4, the positive will be the 2. If you're unsure, multiply it back out, expand it, collect the terms, and check you have the right expression here. So if x minus 4 is equal to 0, then x is equal to 4. If x plus 2 is equal to 0, x is equal to negative 2. So they are the possible solutions to that quadratic equation. As stated, if we only had these three terms and no equal sign, it would become a quadratic expression. So there we go. Nice and logical, nice and straightforward. So let's go ahead and look at some questions, and then we will consider factoring when we have a coefficient on the term in x squared that is not equal to 1. So in question 1, we're asked to factorise the following quadratic expressions. So these are expressions. So if we look at this one here, x squared, if we just go back here, this one, that's the one we've just done. We've done x squared minus x minus 12. So we take the two brackets. It's in the form ax squared plus bx plus c. Two numbers that multiply to give negative 12 and add to give negative 1. They're going in the brackets with the x's, and we see that that's going to be minus 4 and plus 3. If we had, for example, x squared plus x minus 42, this is in the form ax squared plus bx plus c. Two numbers that multiply to give negative 42 and add to give 1. X in each bracket, we're going to have now 6 and 7, x plus 7 and x minus 6. Now if you say to yourself, why isn't it the other way round? Well, let's just do this. If I said it's x minus 7 and x plus 6, when we expand this out, x squared, we're going to have plus 6x minus 7x minus the 42. And we can see that this would give us x squared. Instead of plus x, I would have minus x minus 42. So we can see it's not that one. Okay, we've got 8 minus 6x, and then we've got plus x squared. We need to rewrite this in the form ax squared plus bx plus c. So x squared minus 6x plus 8. Two numbers but multiply to give 8 and add to give negative 6. Bracket, bracket, another one there. If I think about this now, this is definitely going to be 2 and 4. If this number is positive here and this one is negative, then the two factors here are definitely going to have negatives in them. So it's going to be negative 2 and negative 4. If we have a negative number here on the end, we're going to have one positive and one negative. That all comes from the laws of basic multiplication of negative numbers. So that's factored. Let's just do another one. Let's do x squared, and then we're going to have a plus, let's go for 7x plus 10. It's in the correct form, ax squared plus bx plus c. Again, this is not yet an equation. I could make an equation by setting it equal to something. Doesn't necessarily have to be 0. We need two numbers but multiply to give positive 10 and add to give positive 7. Well, if I just think 1 times 10, 2 times by 5, they're the factors of 10, so it's going to be the 2 and the 5, and they're both going to be positive. If this number is positive and this is, they are going to both be positive. Okay, let's just look at this one right here, x squared plus 3x. So we've got now x squared plus 3x. X is common, so we take the x out, and then we're going to have x plus 3. There is no term on here in the constant, so there's no c value, so we just go ahead and factor it. If we had, for example, let's go for 5x minus 2x squared, we can factor this. X is common, that's going to leave me now 5 minus 2x. Much of this will be revision, fairly logical, fairly straightforward. Okay, in question 2, we're asked to solve the following quadratic equations. So this time they're set equal to some value. If we look at the first one, this is already factored. So in the last examples, we were factoring these. We look to factor to solve. So this one is already set up for us. So if we want to solve this equation, either this quantity or this quantity is going to be equal to 0. So we can say that x would be equal to 2 if x minus 2 was 0. If x plus 1 was equal to 0, x would be equal to negative 1. So two possible solutions to the quadratic equation. If we look here, we've got 2x plus 3, x plus 4 is equal to 0. So one or both of these will be 0. Now with this one, I'm just going to do this one first. If 2x plus 3 is equal to 0, 2x would be equal to negative 3 by subtracting 3 from both sides, and x would be equal to negative 3 over 2 by dividing both sides by 2. So we'd have now x is equal to negative 3 over 2. If x plus 4 is equal to 0, then x would be equal to negative 4. Okay, this one needs factoring, and then we're going to solve. So we might be asked to factor and solve. So this one here, we've got it in the form ax squared plus bx plus c is equal to 0. Two numbers but multiply to give negative 8 and add to give negative 2. That will be x minus 4. Then we're going to have x plus 2 is equal to 0. We're exactly where we were with these ones. So we can say if x would be equal to 4 or x would be equal to negative 2. If you want a more formulaic way of thinking about it, whatever the sign is in that bracket, it will be the opposite. Right, this one here. What we can't do here is just do a bit of trial and error. We have to have the right hand side set to 0. Having it set to 6 is not going to be any good for me. See, if I look at that, I'm thinking to myself, well, if that was 3, then that's 3 minus 1, that's 3, so that's 2. 3 times 2 is 6. Just writing 3 down is not acceptable. So what I'm going to do is expand this out. So expanding the left hand side, x squared minus x is equal to 6. I'm going to subtract 6 from both sides. X squared minus x minus 6 is equal to 0. We're now back in the form ax squared plus bx plus c is equal to 0. And this is when we can start to solve a quadratic equation. Factoring is one way of doing that. Now, it might not be the only way that you want to use, but certainly for this one, it will. So two numbers that multiply to give negative 6 and add to give negative 1. Well, that's going to be 3 and 2. We've just got to consider which sign is which. It's going to be x minus the 3 and x plus the 2 is equal to 0. All I'm going to do now is write that x would be equal to 3 or x would be equal to negative 2, and we've solved that quadratic equation by expanding out, rearranging into this particular form and then solving. Not all quadratic equations will factor, and we will look at the skills that we require later on to ensure that we can solve all quadratic equations for real values of x. So there we go. Okay, we're now going to move on. All of the examples so far is when we've had a term in x squared that's just 1. The coefficient, the number in front of the x squared term is 1. What we're now going to do is look at examples when that value of a, the coefficient on the term in x squared, is not 1. So these are in the form ax squared plus bx plus c. The method which I'm going to use isn't necessarily mathematically rigorous. I think it's a nice way. If you want to use a more traditional, more formal approach, I strongly advise you do. This particular way is a nice way of doing it and makes things relatively easy. What we do in this case is multiply a by c. Essentially we were doing that before, but because a was only 1, then we just have that number. So a times by c. So 2x squared plus x minus 1. So let's write this out. Is this in the correct form? Ax squared plus bx plus c? Yes, it is. So a is 2, b is 1, c is negative 1. So we're going to do 2 times by negative 1. Now 2 times by negative 1 is going to give me negative 2. At this stage, I'm going to cheat a little, and instead of putting x in the front of each bracket, I'm going to put 2x. So 2x and 2x. We can see now that we've got this negative 2. So what I'm going to do at this stage is find two numbers that multiply to give negative 2, but add to give positive 1. So if I think about that, I need two numbers that multiply to give negative 2 and add to give 1. We can see that those are going to be on here. It's going to be negative 1 and positive 2. So the reason I chose for positive 2 is this number is plus. If it was a negative, then we'd swap these over. What I'm going to do here is put plus 2 and minus 1. This is where the trick comes in, and again, you might not like this. All we do here is now factor out any terms and cancel them off. So from the first bracket, I can factor out the 2 and cancel it. From the second bracket, I have no common terms, so I leave it like so. So that's what we have. So we've got x plus 1 multiplied by 2x minus 1. And if you want to check, expand it out. X times by 2x is 2x squared. X times by negative 1 is negative x. 1 times by 2x is plus 2x. 1 times by negative 1 is going to give me negative 1. So we get 2x squared plus 1x minus 1 as required. Okay, let's have a go. Let's have a go at the next one. So what we're going to do then is the a times by the c. This is in the correct order, ax squared plus bx plus c. So we can see here that a is going to be equal to 3, b is going to be equal to negative 5, and c is going to be equal to negative 2. We do the a times the c. So 3x squared minus 5x minus the 2. So 3 times by negative 2 is going to give me negative 6. We want two numbers that multiply to give negative 6 and add to give negative 5. They will go in a set of brackets with 3x and 3x. So if I just consider 1 times by 6, 2 times by 3, these are the only factors of 6. We can see here that this negative 5 will be negative 6 and positive 1. So that's what I'm going to do, and just simply put these in. So negative 6, positive 1, I'll put the negative 6 and I'll put the positive 1. We look for common factors. Well, the common factor in this one is 3. That will give me x minus 2. I can cancel that off. And then we have 3x plus 1. and that is fully factored. Again, you might be looking at this thinking that's awful. Perfectly fine. You're more than welcome to do it your own way, and it will give you exactly the same. So that's what we end up with, and that now is factored nicely. Okay, let's look at this last one right here. So what we've got then is 12x squared plus 16x minus 3. So 12x squared plus 16x minus 3. It's in the correct form. X squared, x, no x. 12 times by negative 3 is going to give us negative 36. We need two numbers, multiply to give negative 36 and add to give 16. So let's consider factors. 1 times 36, 2 times by 18, 3 times by 12, 4 times by 9, and 6 multiplied by 6. If we look, these need a difference of 16. Well, it's going to be that one just there. So I want now the plus 18, and I want now the minus 2, or negative 2. So 12x and 12x in each bracket. Plus 18, then we'll have minus 2. Can we factor these down? Well, 6 goes into both 12 and 18. So if I take that out, I'm going to have 2x plus 3. We can see 2 goes into both 12x and 2. So we'll take the 2 out. That will leave me 6x minus 1. We've taken that 2 out, and we can go ahead and cancel these. So fully factored, 2x plus 3, 6x minus 1. If you want to check, 2x times by 6x is 12x squared. 2x times by negative 1 minus 2x. 3 times by 6x is going to give us plus 18x, and then we're going to have minus 3. Those will now simplify to give us plus 16x. So this here is correct, and then I'd write my final answer simply now as 2x plus 3 and then 6x minus 1. As stated, you don't have to use that method, and if you're more rigorous than that, please feel free to use a standard method. I just think this is slightly more accessible. Okay, so these are expressions. Again, they're not equations. So for example, if we were asked to solve 12x squared is equal to 3 minus 16x, then I'd add the 16x and subtract the 3. So we'd have 12x squared plus the 16x minus the 3 is equal to 0. I would go ahead and factor it. That would give me 2x plus 3, 6x minus 1, and that would be equal to 0. So either 2x plus 3 is equal to 0, or 6x minus 1 is equal to 0. So if 2x plus 3 is equal to 0, x is equal to negative 3 over 2. 6x minus 1 is equal to 0, x is equal to positive 1 over 6. We're not asked to do that because they're only expressions. They're not yet equations. Okay, we're asked to factorise and solve the following quadratic equations. So these now are for us to solve. We're going to factor first. If your question asks you to give your answer to 3 significant figures or in exact form, i.e. surds, they're not going to factor. Okay, so is this in the correct form? Ax squared plus bx plus c is equal to 0. Yes, it is. 2 times by negative 3 is going to be negative 6. 1 times by 6 and 2 times by 3. The brackets get opened up. 2x, we're going to have 2x. That's going to be equal to 0. So I want two numbers that multiply to give negative 6 and add to give negative 5. Well, that's going to be the minus 6 and plus 1. So minus 6 and plus 1. At this stage, you don't have to take the common factor out. You can if you want, but certainly when we come to solve them, you don't need to. It's only if you're asked to factor the expression that you need to really do it. The reason being here is I could take 2 out here, and that would just now be cancelled off. Or I could just say that 2x minus 6 is equal to 0, which would give that x is equal to 3. 2x plus 1 is equal to 0, so x would be equal to negative 1/2. Of course, what you could have done is taken that out and written 2x minus 3, and then 2x plus 1 is equal to 0, and then cancelled it like so. or if you want you can divide both sides by 2. It doesn't really make a massive difference here. Okay, let's do the next one. So 5x squared plus 4x minus 1 is equal to 0. Is that in the correct order? Ax squared plus bx plus c is equal to 0? Yes, it is. So 5 times by negative 1. That is the a multiplied by the c, and that's going to be negative 5. So 1 times by 5 are the only factors. It's a prime number. So we need two numbers that multiply to give negative 5 and add to give positive 4. So 5x in each bracket. Set that to 0. I can see here that I'm going to have plus the 5 and minus the 1. So that's going to give me the positive 4. If 5x plus 5 is equal to 0, we could say now that x is equal to negative 1. If 5x minus 1 is equal to 0, x is equal to positive 1/5. Again, you could have factored the 5 out here, entirely up to you. Let's look at the next one. 6x squared plus 7x is equal to 3. This is not in the correct form. We need this equal to 0, so I'm going to subtract 3 from both sides. So 6x squared plus 7x minus 3 is equal to 0. Ax squared plus bx plus c is equal to 0. 6 times by negative 3 is going to be negative 18. So we need two numbers that multiply to give negative 18 and add to give positive 7. 1 times by 18, 2 times by 9, we got 3 times by 6, and they are the factors. So we'll choose these ones as they've got a difference of 7. So we'll have now bracket 6x, close the bracket, 6x, close the bracket, set it to 0. So because this is plus 7, we need the plus 9 and the minus 2. Remember, if this number here is going to be negative, 1 will be positive, 1 will be negative. Again, you can factor these if you wish, or simply solve 6x plus 9 is equal to 0, which would give us that x is negative 3 over 2. 6x minus 2 is equal to 0, x is going to be equal to positive 1/3. So there are our solutions. Let's look at the next one. We've got x multiplied by the quantity 2x minus 1, and that's equal to 15. We're told it factors, so I need to expand the left-hand side out, collect the terms up on the left, and look to refactor and solve. Don't just start plugging numbers in here for x that are going to make 15. As you'll see, we're expecting two possible solutions, and that trial and error method is not valid. Expanding out on the left-hand side, 2x squared minus x, that's equal to 15. 2x squared minus x minus the 15 is equal to 0. Ax squared plus bx plus c is equal to 0. A times by c, well, that's going to give 2 times by negative 15, which is negative 30. We need to make a number now. Two numbers that multiply to give negative 30 and add to give negative 1. You might be able to jump straight to this. It's going to be 6 and 5. They've got a difference of 1. So we're going to have now negative 6 and plus 5. So we'll have now 2x minus 6, and then we will have now 2x plus 5, and that's equal to 0. If we solve this factor, either this one is 0 or this one is 0. If that one is 0, then 2x minus 6 is equal to 0, x is 3. If this one is 0, 2x plus 5 is equal to 0, 2x is negative 5, x is equal to negative 5 over 2. Two solutions, job done. Right, let's look at this one just here. We've got 0.4x squared plus x is equal to 0.6, and we need to factor and solve this. I think at this stage we can bring in fractions. As soon as I bring in the fractions, it might make things easier. So 0.4, well 0.4 is 2 over 5, so 2 over 5x squared, plus, now we've got x. Now I could write this, I don't have to, I could write this as 5 over 5x. I probably wouldn't want to, but at least now we're going to have all of these in now fractions over 5. So from that I can see that 2x squared plus 5x is equal to 3. Multiplying through by 5, again you didn't have to, once you multiplied x by 5 you're going to get the 5x. We'll We'll subtract the 3 from both sides. 2x squared plus 5x minus 3 is equal to 0. Ax squared plus bx plus c is equal to 0. A times by c, 2 multiplied by negative 3 is negative 6. We need two numbers that multiply to give negative 6 and add to give positive 5. Well, that's going to be plus 6 and minus 1. 2x in each bracket, so we'll have 2x and 2x. We need to insert these in. I'm going to put my plus 6 here. I'm going to put my minus 1 here. 2x plus 6 is equal to 0, then x is equal to negative 3. 2x minus 1 is equal to 0, x is equal to 1/2. Okay, so there we go. Nice and straightforward. Now, if you want to check that this is going to work, then you can plug it in. So let's say you're unsure and you've got a calculator to hand. Let's try both of these solutions. So what we've got then is 0.4, and then we'll square the term, plus now the term. And if I substitute in these two numbers here, once, I'll do negative 3, we should get the 0.6. So let's go ahead and put these in, and that is going to give me 0.6 as we expected. And then if I switch this over to 1/2 with 0.5, it will satisfy this equation. So when you're doing these solutions, do check that they satisfy, both of them satisfy the original equation. So as we can see, we've got 0.6. So there we go, factoring and solving quadratic equations. Okay, let's do one more. In question 5, it says in part A, given that the quadratic equation f of x is equal to 2x minus 3 multiplied by 3x minus 5 can be written in the form ax squared plus bx plus c, find the values of a, b and c. Okay, so all this is asking us to do is expand it out and just rewrite it. So let's do that. F of x, this is just a function of x. F of x, you might see y is equal to, or you might have some number. This is just a function. 2x multiplied by 3x is going to be 6x squared. 2x multiplied by the negative 5, well, that's going to give me minus 10x. Negative 3 multiplied by 3x, well, that's going to be minus 9x. We've got negative 3 times by negative 5, which is going to be plus 15. So we can tidy this up. 6x squared minus the 19x plus now the 15. And that gives us the quadratic in the form ax squared plus bx plus c. So a is going to be positive 6, b is going to be negative 19, and c is going to be positive 15. It's important to remember those signs. Certainly when we come to the quadratic equation or quadratic formula, you will really need to consider the positives and the negatives. In part B, we need to write down the solutions to the equation f of x is equal to 0. Well, let's just set this equal to 0. So all we've got then is 2x minus 3 is equal to 0, 3x minus 5 is equal to 0. So, back to where we were. Either this one is 0 or this one is 0. If this one is, then x is going to be positive 3 over 2. If this one is, then x is going to be positive 5 over 3. Nice and straightforward. Okay. In part C, we need to find the solutions to the equation f of x is equal to 15. I could set this equal to 15, or I could look at this and set this equal to 15. So if I set this part equal to 15, 6x squared minus 19x plus 15 is equal to 15. We can subtract 15 from both sides. So 6x squared minus 19x is equal to 0. What we've got here is ax squared plus bx, and we looked at factoring those before. So here we don't have a constant term. What I'm going to do is factor the x. I've got x is common to both. We know that's going to lead, if we don't have a constant, to x multiplied by ax plus b. X into 6x squared, or what is 6x squared over x? The answer is 6x. What is negative 19 over x? Well, the answer is negative 19. And that is going to be equal to 0. No common factors in terms of the numbers, as 19 is a prime number. Either x is 0 or 6x minus 19 is equal to 0. So as a fraction, it would be now 19 over 6. So all we've done is simply plug those values in and gone ahead and solved. So there we go. That now is a brief introduction to quadratic equations. We've looked at factoring and then factoring to solve in the form ax squared plus bx plus c is equal to 0. In the next video, we'll look at completing the square, and then finally we will look at the quadratic formula.